order. Good morning. My name is Wee Pham. I work for Chevron Energy Technology Company. I manage the process automation system group, which we also part component of that is safety system group. Okay. Anything else I need to?
Yeah, share what Chevron's approach to the safety integrated versus non-integrated.
Oh gosh, very complex. Because Chevron is an integrated energy company, so we have upstream oil and gas, we have midstream pipeline, we have downstream refinery and chemical. And so it's kind of fall into the both situation, and then you add the component that Chevron is more of a federated company, so we have different unit globally, and so with that we also I guess it's a mixture of both, doing the right thing, but also the OC, meeting the OC and functionality, cybersecurity, and also the legacy, and the so meeting all that, we have all the place, different practices. So I guess I can, based on the question, I can go into the specific, right?
Yeah, okay. Scott.
Good morning, everyone. I'm Scott Moyer with Dow Chemical. I'd like to think I offer somewhat of a unique perspective to it. I came into the Dow organization through the Union Carbide merger in 2001, and many of you know, some of you don't know, Dow has its own proprietary control system that has a formal third-party safety certification, but it also integrates basic process control, regulatory control with safety system applications, and Dow's leveraging that use case and migrating away from owning and developing that system into implementing a commercial system. And the commercial system that they have chosen also integrates control and safety, but at the same time, through various and sundry mergers and acquisitions, we have a wide variety of process automation safety system implementations that also include those products and those systems that are completely segregated. So we kind of have a mixed bag, and where each one is going to be implemented, a lot of it depends on the circumstances. And well, obviously there are advantages and disadvantages, and that's one of the things that we hope to be going into those discussions as part of this panel.
Okay, David.
Good morning. My name is Dave Dybert with Air Products. I've been with Air Products 41 years, all that time in automation. Currently work in the technology group, and I work across all the businesses and operations in terms of advising and dealing with process automation systems, which is everything from the moment-to-moment control of the plant. It can be BPCS, asset protection, as well as safety systems, SCADA, HMI, et cetera. In terms of the plants that we have and the systems we have, very similar story. Our operations group, which has 750 plants over 50 countries and 1,800 miles of pipelines, would like to say they have one of everything, and that comes with a challenge. But we certainly have, old-fashioned hardwired systems. We have non-integrated systems. We have systems that I classically call shared one zone and shared two zone systems. If you're familiar with S84, TR09, and any of the CCPS books out there regarding safe automation, they have them broken into various architectures and hopefully help to explain some of the pluses and minuses around that.
Okay.
Hi, I'm Chris O'Brien with Exida. I'm Exida is an ANSI accredited certification body, so we're not an end user or process owner. But what we do is we do certification for functional safety, IEC 61508, and cybersecurity, IEC 62443. So we get to work with a lot of end users and a lot of OEMs and get insights into different designs. And we would probably say, or I would say that, there isn't one right way. It's really understanding the system design, what are the vulnerabilities of that design, and integrated can be good and separated can be bad and vice versa. So it's really, having a really good insight into how that system, what is the system, what are the vulnerabilities, and what's the mitigation.
Great. So with that, is there anybody with the first question? There we go.
I'd like to hear from the panel their perception on some of the cybersecurity threats as it pertains to an integrated versus a non-integrated system. Are they the same threats, or are they uniquely different? What, from a cyber standpoint, what keeps you up at night?
Anybody?
Well, I'll kind of address it. I'm to a certain extent, based on my background, I'm largely going to claim ignorance on that general topic. But everybody is in this day and age is certainly aware of issues and concerns. From my perspective, and Mark kind of touched on that as well as Chris, that regardless of integrated versus segregated, you still have issues. You still have to follow the appropriate implementation and do smart things. There are incident reports on breaches that have occurred on regulatory control systems, and someone could try to extrapolate that data and say, okay, if this system happened to be doing both in the shared box, then not only could it have compromised the regulatory control, but it also could have compromised the safety protective functions, and they could have potentially overwrote those. At the same time, we heard of a recent incident that occurred with a completely segregated system. And it came to be, for those of you who've read into the details, it was just the way the owner operating company had that system implemented. They just did not follow smart implementation standards, and they just left the door wide open to Pandora's box. So regardless of the type of architecture, you still have to do smart things. Now, at the same time, you almost have to ask yourself, well, what kind of open access do I want to have with this system? Where is the data going to be used? How is the data going to be used? What data is needed? And then, based on that approach and what you're trying to do with your architecture design, you have to put in the appropriate procedures in place, regardless of whether it's integrated or segregated. You still have to do smart things.
Okay, yeah, I'll go. So from our approach, because we have both integrated and non-integrated, and as far as the link to cybersecurity, what our general approach is, I think I heard it before in earlier session where we kind of bucket or zone. We take the zone approach is let's bucket the SIS system in a bucket. Really truly understand what are all the risks associated to that, is either from top down, from network connectivity or from the field. So understand and manage those risks. So manage those risks, we take approach from from the early stage design, we have processes to identify and put in place risk mitigation into the design and the processes. And from the life cycle, as far as testing what needs to be tested, we also, like our colleague in the industry, we are heavily involved with the Department of Homeland Security Logic Initiative, where there's multiple projects, but one project is we look heavily into testing of different supply system and integration. From our viewpoint is, if you look, majority of the incident, cybersecurity related incident is more of, I don't know the right term to call, but I call it physical. That's human, that's USB drive, that's leave the door open or somebody get onto the workstation. We worry more on that, and so that's our highest priority. How do we physically manage that versus the integration aspect through the network? We still manage that, but it's not as focused as more the physical.
Yeah, I'd like to echo, a lot of what was said before, but certainly you have to analyze both systems. There's not one system, that's the panacea over the other one, okay? And you can't live today in, let's say, a safety silo alone, where I read the safety manual, I choose my functionality and independence that I want, and I have a safety trained person, and turn your blind eye to cyber. Cyber has to be a part of the whole process, starting with security vulnerability assessments, where you decide where's my risk, okay? And can't stress enough that goes from the top to the bottom, to control your field instruments, which are most cases are hard of some sort, okay, or somehow programmed, okay, all the way up to the integration layer. So when I like to think about it in terms of the functionality independence and your access security, all of that is part and parcel to the hardware, the architecture that you pick and choose. Then the next layer on top is procedural, and it's your management of change, it's your auditability, it's what are the pieces and parts that you need to keep track of who's been at the ES, for instance, who's certified, who's not. Should I have let's say a BPCS user or engineer that's separate and independent from my sys engineer, and what are those risks and how do I want to manage that? And all of that leads up to I'll say the top of the pyramid, which is the integrity you need and the reliability you need in the plant. So I think you have to think through all of that, okay, in order to have an effective sys and an effective plant.
And then, like one perspective that I would add from what we see is, this is a classic case where the general cybersecurity vulnerabilities of getting access to two systems at the same time would be a concern. But it's a case that could show that the vulnerability could be in something like a communication stack or in software. So if a vendor is reusing code between a safety and a control platform, there's a vulnerability. But another thing even is, a lot of communication stacks are third-party supplied. And you can buy a communication stack, you can buy communication drivers, you can buy source code. So you could wind up with vendor X and vendor Y with the part of the system that connects to the outside world identical or almost identical. And that's where I'm say certification, I'm not pushing certification, but that's where, like, if somebody's done a 62443 4-1 development process, there's a security development lifecycle that says, hey, you need a coding standard that defends against these types of things, or 62443 4-2, which is testing these devices. So that's just a good example of where something that looks very diverse, completely different from two different vendors, could have the same vulnerability that, without asking that question, you're never going to know. And the two vendors aren't necessarily going to know themselves that they've done part of that design identically.
Okay. Another question in the back?
Yeah, my name is Mark Duck from Shell, and we have both as well. But if you were looking at a greenfield for your given company, what would be a couple of criteria that would drive you to integrated versus non-integrated? Thoughts on that?
Sure, I'll start. A couple of things that we look at. A lot of it where Dow feels that we gain a competitive advantage in doing our automation implementation and our regulatory control strategies is the integration of the process operation and using state-based control to migrate through different phases of the startup sequence, potential shutdown sequence, and various modes of operation of the process. Some process designs really can have an advantage on using that type of an implementation. And when you have that type of an implementation, oftentimes you gain even more advantage of having it tightly integrated into your safety system operation and communication of information. Now, that's not to say that the basic process control system is writing changes to the safety system. It's a matter of sharing information in an advantageous fashion, something that you could take advantage of speed of communication by having this integration system versus doing something that would require extra programming for communication protocol. So that's a piece of it. Another piece of it would even include just your general I/O count and the percentage of I/O associated with safety versus percentage of I/O associated with regulatory control, and how that I/O matches up against process design equipment, and whether you're integrating all of that, how you're going to run a column, how you're going to run a reactor. Is it going to be multiple reactors? Is it going to be a batch process versus a large continuous process? Is this a continuous process that typically is going to run 5 or 6 years between turnarounds? A lot of those things in that decision, in the design of the process and design of the operation, and how you're going to be making product for your customers, that largely drives the consideration of integrated versus segregated. At least that's how we look at it.
Yeah, I guess I'd echo a lot of what Scott has said. I mean, certainly we deal with small plants with non-integrated SISs with 5 safety circuits that don't really need to talk to the BPCS very much. And on the other side of the house, we deal with very complex logic and integrated logic, such as Scott is talking about, in terms of, sometimes the safety system needs to act on asset protection, for instance, in the BPCS, and sometimes vice versa, okay? And particularly as you bring voting and shared systems into the picture, then integrated has a broader play. But certainly, we look at cost, you look at operability, you look at flexibility, you look at engineering flexibility of all of that. You pick your bag, so to speak, pick your choice, okay? But then along with that comes the management functionality and the management needs at the plant, the support needs at the plant. And so, you need to marry both of those together in order to get an effective answer.
So, I know within Shell, that's a very, broad, open question, because if I go through, participate with a project, I have a laundry list to determine that. Anything from, I'll start saying we are a federated company, right? So we have in Angola, Australia, first thing is technology. What kind of skill set do I have? What kind of service do I have there? Secondly is also what kind of operation philosophy that drive my functionality requirement there. And whatever technology, integrate or not, that drive that. So there's a whole slew, and also in design, right? There's certain part where it makes sense. Anything from a greenfield of a complex plant versus a well pad, right? So what can you do to design your process so that you bring it to a level where you can support, right, and mitigate the risk? So that it's a slew of activities, and then once we get the design or the decision in place, then we'll do assessment on what's our risk of each of those components, and we have planned to mitigate those risks. So there's a checklist of items that we need, and it's all depend on the greenfield projects.
We don't really do greenfield projects, but sometimes how we would get involved with something like this is if we have a customer who maybe started the, train down the track and then realizing like, oh, we're not really kind of meeting our corporate standards, or we don't have a design that we're comfortable with, and then we would, come in and probably help with, from a risk perspective, what's the highest risk, either from the process risk, or if we looked at the capability of the organization from management systems and people and training, and then how do you mitigate that? And realizing, it's a long journey, and they're not always going to get there immediately. So, but we typically would come in a little later in the life cycle.
We have another question?
I'm Tim Salisbury with LyondellBasell, and I have a couple of questions. I guess let me first state my bias that we're also a company made up of mergers and acquisitions, so we have one of everything. And I'm kind of a believer in interfaced but not integrated, because we can have a certification that the logic solver is secure, but you also need to look at all the other common mode failures that could affect that, like the programmer or an asset maintenance system that could potentially respan a valve or change an instrument. So interfaced but not integrated. But to that end, the questions are, we're starting to see a lot of benefits of having additional interface, like being able to get health diagnostics out of the safety system, or being able to have a more integrated operator interface so they can tell which interlock is keeping a pump from starting, that sort of thing. So the question is, have any of you considered, are you using data diodes or unidirectional gateways to be able to get that data out, but yet be 100% confident that there is no way that an unknown vulnerability could be taken advantage of? Because probably your safety system hasn't been patched at the same frequency as your upper level systems. That's one question. And then the second is, do you see changes in the regulations or the standards related to safety systems driving us to be more integrated? For example, I've heard comments that perhaps the updated safety system standard would require you to use the health diagnostics, and if you're isolated or only interface, that might be hard to do. Sorry, that was kind of long, but you can chat however you want.
Okay, so there's, did you write that down? Lee?
I got it. Data diode and standards.
Okay, go ahead. You get to do it first.
I guess your first question is, have we considered data diode as for, and to your respect, is interface versus integrate? Yes, we have looked at data diode. We have we tested, we pilot some, and I think our first deployment in a small scale, we have that in plan. The issue is you have to balance this with the cost, right? The benefit and the cost. Right now, this is, to us, there's a lot of benefit, but is it worth the cost? And that's why we try and do that. As far as interface and integrate, years back, before my time, it was segregated and with interface. When I started in my time years ago, the issue with, we always encounter, at least from our perspective, the issue that we drive toward integration was the challenges of interfaces. So plants always, either you can say you did a very good job as far as interface, the system doing project phase, right? And you test it and everything. But the challenges is through the life cycle of the plant, there's always going to be a request for changes, and how you manage that change, and you have the right skill set to do that, and we all meet that. And we find that's a challenge. You give operator one functionality, and after a day, they're going to ask for 5 more different. And so that's one. As far as standard, and I'll tie it back to, I think, one of your original, somebody was saying, what keeping us up at night? Well, I can't speak for the operation group. I'm sure there is running the plant, but really from our technology is having an industry standard that's saying you need to do this or the other one. That's what keeping it, especially segregate and those, I think we have a robust system where we understand a process to understand the risk and have in place how do we mitigate that. So,
one thing that, as far as the standards, I'm not aware of anything with 61508 that's driving it to become prescriptive, to say thou must do a certain thing a certain way. So it's a performance-based standard. It's focused on, you can claim diagnostics, and there's maybe different ways to get them, and there could be some benefits of integrating that information, but not required. And I really don't anticipate that changing. One thing I think that is going to impact, and we've seen it not so much in the petrochemical chemical yet, but we've got some, companies that are global food manufacturers and processors and different things. They have all different kinds of plants, and I got a call, they want to put an automated vehicle in here to move stuff around, and they said it's fail-safe because if it loses the Wi-Fi connection, it stops. It's like, well, no, that's not a sufficient risk analysis and design analysis to put a 2-ton vehicle moving around your plant with people. So some of those standards do have prescriptive, they're based off the machinery standards, and they'll say, okay, well, you've got to be hardware fault tolerance of 1 in category 3, which would have a defined diagnostic coverage and comparisons to be done. So that, I think, is going to touch on our market segments, but I don't think it's going to change 508, and there's always the continuing discussions between the different types of standards and approaches.
I guess I'll add that, yes, we've looked at data diodes, and yes, there's applications where deep packet inspection firewalls and things of that nature come into play. It all depends on the system you have and the risks that you see. I would make a comment about standards, and I kind of echo what Chris is saying. S84 is a performance-based standard. I'm not aware of any move to make it more prescriptive. S84 Technical Report 9 is what I call cyber and the sys, and that's also a performance-based standard. And if folks are here looking at S99, there's a working group 7. Eric Cosman is here somewhere in this areas, and I'd encourage you to get involved in working group 7, which is the tie between S84 working group 9 and S99. And I'm not aware, again, of other prescriptive answers, and I would personally avoid, my own opinion is I would avoid prescriptive answers, because there's too many too many opportunities, too much risk. The risk is different for plant A versus B versus C.
Yeah, just to add as well, I think you touched on a couple of key points in the consideration. First of all, to address the data diode question, I'm not aware that we have them in place. That doesn't mean I know of every single automation implementation globally across Dow Chemical, but I'm not aware that we're using that. But you certainly have to take into considerations the challenges in integrating diagnostics, in integrating and developing HMIs, consistency, efficiency, and is that going to drive you in the direction of integrated versus segregated systems? It has to be addressed. It has to be looked at. With systems being more sophisticated with their diagnostics and information you want to make available to your maintenance technicians, to your operating technicians, if you have systems that are completely segregated, completely different platforms, completely different hardware, completely different development tools, well, now you have the challenges of how to get that information into your operators. Now, that's not saying that you can't do that and you can't do it in an efficient manner, but it has to be addressed. And you have to get the appropriate folks trained, qualified, certified, whatever you want to call it. And that could be a disadvantage to an organization, or it could be an advantage to an organization. You could have a key group of subject matter experts that are highly trained individuals on doing these implementations, doing them consistently per corporate standards and implementations across your entire company, and they just go from place to place. And they know how to make it work. They know how to do it efficiently because they've done it before. And you've eliminated the issue with common cause because you do have this specialized trained group of individuals and they're doing it for you across the company. That's one approach. The other approach is we really don't want to be able to maintain that. We want to be able to cross-pollinate, allow people to migrate into different areas, different disciplines, have different skill sets. And we're going to manage access through appropriate user accounts. We're going to manage access through these systems that have these protections already built in and make sure that we implement them per their safety manual and our corporate implementation guidelines. So different approaches, different ease of implementations, challenges of implementation, challenges of doing communications and getting information to the right people.
Oh, can I just add some more is relating to data diode. I just realized also is as we go through design and we can build these technology to make it safer, but one of our struggle also is relating to OC and merging of IT/OT, right? There's certain part of our global that we don't have resource to do that, right? So we are very much, in some area, we're very much on our early journey of management functional safety, and then early journey as far IT/OT, certain place we don't have. So it's easy to put it in, right? But how you keep it running in middle of, I don't know, in the jungle somewhere. You know, something happened, what do you do? We have to be aware of that, so that's part of it.
Okay.
All right, so this question is more on the, let's say, on the processes or work processes, life cycle aspect of it. I think the previous question briefly touched on an assumption, I think, that the safety system might not have the same frequency of patching for operating system or antivirus or whatever other security features, functionality, software associated to it. So that triggered the question of, from the security life cycle perspective, do you see advantages or disadvantages on your security management activities of one approach versus the other?
From my level of experience and understanding some of the different platforms, we joke about it internal to Dow. I'll give you the Six Sigma answer. It depends, obviously. In the early days of distributed control systems, everything was proprietary operating systems, proprietary configuration. The vendors kind of did their own thing, and there was no commonality, and they ran on their own boxes. Well, now, in this day and age, everything seems to be more Windows-based and server-based and involvement in those activities. And as a result of that, you're definitely seeing more vulnerabilities to the various operating systems. And the suppliers of these systems aren't in control of those operating systems. They're only in control of the software that they develop that run on those systems. And it is a challenge. It's a challenge for owner-operating companies to try and stay up to date on those things. And when Windows comes out with something that says, oh yeah, well now you have to do this because we just found this vulnerability, we now have this patch that has to be done, you have to be smart about how you manage that and understand the impact. And I think in developing your organization of support, they also have to have the right individuals that not only understand those systems, understand the vendor software that runs on those systems, and partner with the vendors as to, okay, is this a vulnerability? Is this something we need to worry about? How do we actively do this patch management philosophy? And what is the impact of our operating system to do these things? Do we feel that, based on this information, we really are vulnerable as an operating company? Or is this something that, based on the architecture of our design and the implementation, that we feel we've done an appropriate risk assessment? And there's a lot of discussion about approaching security design the same way you approach safety design. You do it as a risk-based approach. If there is an appropriate risk, then you have to deploy the right resources, partner with your suppliers in doing what you need to do, but you also have to know what that impact is, and that's what's going to be driving it. Whether the system's integrated versus completely segregated, I think it depends largely on the architecture of each individual system. And are you relying on Windows-based boxes that require these kind of patches? The other piece of it is, how are you deploying your engineering tools? If it's done through common laptops, workstations, where you're using the vendor software to do development, then you're pretty much responsible internally for ensuring that those systems are up to speed and you're doing some smart things on doing your access.
Yeah, I guess I'd like to add, the first question really in my mind is independence of the SIS from your BPCS, and how you want to design it in terms of the architecture, in terms of the data flow, and in terms of how you want to conceptually lock down your SIS, from proof test to proof test, okay? At the same time, certainly the components that were raised here are valid, okay, particularly in the ES side of the house. I think we also need to pressure suppliers and work with the suppliers for the right tools, comparison tools, things of that nature, in order to validate that what you're downloading to the SIS is as exactly what you think it is, okay? And so there's a lot of different aspects. I think you can't stress the functionality and independence component, and you can't stress enough the cyber vulnerability assessments that should be a part of every design.
And the first question I would probably have for a client would be, how far are they kind of through a maturity model approach? So, do they have a cybersecurity management system? And do they really have it? Are they in agreement across IT, OT? Are they working together? Is it communicated through the organization? Is it staffed through the organization? So, some organizations are really good, and some organizations don't really quite understand what they need to do, and they might just be doing patching but not doing it effectively, and so it doesn't matter what they're patching, and they're doing one little part of a big puzzle. So
I guess if I understand your question right, I'll try to answer. I don't think the association integrated system or not, the decision as far as the safety aspect, like patching and all, I don't think it pay into the criteria of an integrated system or not as much as really the functionality. Really drive functionality, and then whatever the risk of, we identify cybersecurity risk for that safety, part of that is having process and procedure in place. One of our drive now, our standard is, hey, so we understand our highest risk is the physical part. I was saying, one of our practices, shut off the engineering station, then manage it through MOC whenever you need to make changes. And it have its patching cycle, part of procedure is have you test that on the bench. Does have any, so we have process procedure and manage as a system. Part of the integration is mostly driven from functionality and the requirement for getting the data.
Good morning, Bob Whitaker with Shell. I'm curious for the panel's view on some of the opportunities and challenges perhaps that are coming with the emerging digitalization trends that we see out there, the open standards such as OPAF, the Industrial Internet of Things, Industry 4.0. What are some of those opportunities and challenges that you're looking at or seeing these days?
Nobody's jumping at the mic.
I'm sorry to process it. As far as the digitization transformation part, we see that's a great opportunity. So a lot of part of Intergrated allow us to have more data. Now, how do we make better of those data? And
Can you hear
so,
him? Can you hear him? Okay, super.
Oh, sorry. I guess I have to hold. So we see that as an opportunity. So we kick off different projects within Chevron on how we take those data and make it better use of it. So we create things like heat map of where's where your risk area of the plant by looking at what part of it and bring it to the information to the right group of people, right? And so we see that as a great opportunity. We definitely see the benefit of OPA and OPAF activities. We participate in it. And I agree with directions right now. Let's put the safety system aside first. Let's address that part. If we address the control system and the challenges and how we get more data, more integrated type data and not interface, then let's do one step at a time. I think we still, at this point in time, we still keep the safety as a separate.
Yeah, I mean, I would agree from the viewpoint of let's start at the BPCS layer, okay? But conceptually, there's nothing wrong with the SIS reporting things out, okay? In my mind, the problem comes if you want to write something into the SIS, which in my opinion is the wrong answer, okay? So it's how you choose to guard that data. I think there's a lot of opportunity and a lot of pluses that can come from the SIS reporting things, whether it reports data that you can then reaffirm in your SIL assessments and SIL verifications, or your proof test procedures or whatever. I think there's value there. Today, we do that manually, okay, with procedures and people. Tomorrow, I'm sure that could be, through digitization, and I expect it would be.
And I think that's probably one of the key things. I would think that the more connected it is, the bigger the system then is, and then you've got to, if you separate safety out and say, well, we're really not going to do changes in that makes sense. But then from the cyber vulnerability, now you've got, all these additional ways things can be compromised. And then going with the safety data, I think that, as Dave said, as we can collect more data, we could really get a better idea, really, what is the demand rate? How often are these protection layers actuated? And then an issue that, isn't quite as sexy as cybersecurity would be, well, hey, if I'm using this valve in a pretty benign clean application, here's the realistic failure rate. If I'm using it in chlorine or a slurry or somewhere else, here's a better failure rate to use. So then we can take this quantitative modeling a little bit further, and we think it has a lot of benefit now, but that definitely is a challenge of, the two ends of the safety system, the transmitters and the valves, really do behave differently in different processes, and even within different plants in the same organization. We've done studies, we've seen almost a 2x difference in failure rates, same equipment, same operating company, different plant. So I think that would be a big benefit, because we all kind of know we want that data, but there's no way to get it right now.
Yeah, I think the challenge is, at least from excuse me, at least from my perspective, in my previous life as an engineer with Union Carbide, I was also responsible for the field design, which included sensors, final elements. In my current position, that's another discipline that handles that, but I tell everyone I know enough about it to be dangerous. There's a lot of improvements going on with sensor technology, smart sensors, additional diagnostics. But what you have to ask yourself at the end of the day, does my safety system, does my safety function need to know that information? And if so, how do I ensure the integrity of the information? How do I ensure it's in essence management of that data, management of those devices? And I think where we are what I'm seeing as an industry, from vendor A to vendor B to vendor C, as far as sensor design, there's different approaches to what information they're making available. And if it is just only for the purpose of asset management and maybe knowing the health of the device, or maybe the health of the piece of equipment that it's monitoring, versus the specific information that is being used in the safety function, you have to be able to manage that appropriately. And there has to be a certain amount of protection of, change management of the configuration of the device, access restrictions, those kind of things. One to throw out that's, coming of age is wireless sensor technology. Well, I'm not aware of anybody in our common industries that's willing to use a wireless signal as an input to a safety function. It's just not a proven enough technology. We're testing it. A lot of companies are testing its viability in regulatory control, monitoring, remote tank farms, things like that, but not in the area of protective functions, at least not that I'm aware of. I think there's still a lot of unknowns out there. I think there's still some cyber issues around protecting the integrity of the device, ensuring that, it's live versus somebody has taken it offline and just entered a manual value and you're not seeing any process condition change. I think there's a lot of issues around where that technology is going and when it will be advanced enough and have a high enough integrity that we could use it as part of safety functions. Until then, it's just information for asset management, and that has to be, in my opinion, it has to still be segregated away from your safety functions because I don't think the technology's there yet.
Good morning, Brian Clemens, Dow Chemical, and I am not a safety systems expert, but it doesn't mean I haven't had the opportunity to work in it. And I think this question and discussion is a great lead-in. Early in my career, you really only ever saw systems and safety systems and fired equipment. I was more focused in instrumentation. My first safety loop was a simple module that took a temperature input, had a dual, normally open relay. It was closed loop. Same kind of testing procedure. So with technology advancement, with open, with computing on the edge, is there an opportunity, I hate to say this, to segregate even further, have BPCS, safety, and edge? And I may be asking you to speculate, but I'm curious to see where you see that going.
I guess it's a speculation. My perspective is that, the safety business is really a risk-averse business, right? We're not going to experiment with new stuff, on the SIS. We'll experiment new stuff, on the BPCS side of the house, if you will, or, in other areas of the plant that show gain in value. So, from my perspective, I don't see that necessarily happening. We certainly have cases where you have independence and certainly have cases where you have hardwired SISs because you don't necessarily need programmable devices. But I don't see that at the moment, okay, in terms of edge devices coming to the SIS.
Yeah, I'll take a stab if I understand your question right. As technology progresses, like you mentioned, I think technology is an enabler. And really, from what we do in the safety system, control system, we kind of bucket, right? We assess in terms of those information that needed to operate the plant safely. And then those information or data that will enhance the production or decision making of the operator. So we kind of bucket that, and where we see with all these advent of the IoT and all these, it's really on the other bucket, the enhanced of the decision, and not really to operate the plant safely, because we already did. We have quite a robust process to make sure that we got enough information to operator to operate the plant safely. So so I don't see, as far as the advent of technology in terms of more data, more field data will drive any conclusion or decision on either integrate or not, if I understand your question.
I think I'll clarify it a little when I talk about further segregation. A single sensor final element loop out there on the edge. That's no additional level. So is there opportunity there?
Is there opportunity to have additional sensor at the edge to enhance the system? Is that your question?
Do maybe like quantum level safety where you would say, hey, I just need to protect this and I'm going to put it there and it's living by itself? Yeah, I think that probably plants would still, from my perspective, it would be kind of the scale or the deployment. So if there's only one protective function, it still might be done by a switch to a solenoid, to a valve. So it's not super elegant, but it's effective and it works. So I think that those things still exist. It seems as plants get bigger or more integrated, then it's that benefit discussion of, hey, if I spend a little more on the infrastructure and I integrate these functions and I can read data up, does that offset the complexity of adding it? So I think that some of those things are happening now, and it's not cultural, but benefit trade-offs of how they deploy it. I think, if I got that.
Yeah, I think for me, fundamentally, implementation of safety functions is still around risk mitigation. That is the driver. And depending on the level of integrity needed, how much risk reduction credit you're taking, it is a formal process through the safety life cycle to do the hazard assessment, ensure that it complies with your company's risk matrix or whatever you're using to do the quantification, whatever tools you're doing. Ultimately, it's going to drive the level of integrity of the design. Now, can we achieve that level of integrity using that sensor and implementing the function using edge technology and then into a final element? Well, that's where Chris's guys got to go in as a third-party certifier and saying, yes, this black box that's doing this edge computing, it has been thoroughly vetted, and you can claim an equivalent risk reduction associated with this range, provided you implement it in such a fashion. If that happens and you go through that formal third-party certification that will qualify that technology to claim that risk reduction, then there's no reason why you couldn't do that in certain cases. Now, whether that is the direction that your organization is going to want to head, that's another conversation. But ultimately, it's got to be driven through the safety life cycle. If you're claiming any kind of risk reduction associated with it, you still have to follow the appropriate standards, international standards, in driving that implementation.
Right. What you're saying is trust the process. The process gives you the hazards analysis, it gives you your targets. How do you achieve those targets? And of course, the other part of it is your cyber aspects of this, which walk side by side, if you will. So, I guess you should never say never, but it's hard. At this stage of the game, is it the best answer from a cost perspective, a reliability perspective, an integrity perspective? And don't forget the maintenance side of the house, or your support mechanisms, for that particular plant and that particular device. We all have folks that come with, let's say, new ideas, and when you play out those new ideas, the overall cost of ownership may overshadow, really, some of the other classical approaches.
I'll go back to my point. It's very important to us also. It might be that, hey, this solution might mitigate this risk, right? Going back to OC now. So we be very, for us, very cautious on how are we going to support this thing, right? So now you're introducing a very complex technology that maybe require, IT skill set, right? So now and it's safety, so now how do I mix, middle of the night, do I call both safety and IT? And, so that's very important to us, because that's really one area that we struggle as far as keep introducing technology, make sure that we have the skill set.
Okay, over there.
Hello, good morning. My name is Chris DaCosta. I'm with Air Products and Chemicals. I'm the OT Cybersecurity Manager. And just full disclosure, I work very closely with Dave Dybert up there, so you're not allowed to answer this question. I'd just like to ask the panel to comment on penetration testing for those who have integrated safety systems. After you've done your PHA and you understand where your risks are and you've developed an architecture, have you then gone ahead and done any kind of penetration testing to just verify or validate that you've covered everything. And again, in full disclosure, we have done that, and it has revealed some things that we wouldn't have thought about.
One of the things that we are doing, and I'm not sure at what point the formality of the activity has gotten kicked off. We have always gone through an appropriate assessment of our architecture design, once it's been implemented prior to commissioning, doing, if you will, hardening of the system, making sure that the USB drives are locked down and the appropriate account accesses have been put in place. But we're now taking another approach in bringing in some additional expertise from a cyber design standpoint. Because we're doing more things in integration at an MES level, we're now doing more of an independent group of assessors going in, looking at those things. Now, whether you would consider it a formal penetration testing or anything like that, I personally don't know the details of that. But I know we are looking at not only the hardening phase, but also issues around remote access and what kind of information is being put together, what kind of remote access needs are there, who has the remote access, those kind of things. So we're going into a lot more of a deep dive into that design and ensuring that the architecture is robust and it's appropriately protected.
So we've not really done any online penetration testing. One thing we do with, and I hope, I got to shit, we've gotten calls from customers who's had their IT inadvertently do online penetration testing and shut the system down. But part of 62443 and the ISA ISKI standard is communication robustness testing and testing those interfaces to networks to see what they can withstand. So to that degree, that we do that, but we haven't really, I haven't seen it evolve to a deployed system level, even in an FAT point of trying to test the system that way. So it seems to, from my perspective, it still seems to be more box by box testing.
So our approach, we have multiple activities relating to penetration testing. Everything starting off from the technology, where we qualifying a solution. We perform that, and also that's linked to the logic program with Homeland Security. All the way to project, where part of our FAT, integrated FAT, is we have a process and tools to do penetration, and to the life cycle where we have two factors. We have a group that do planned penetration tests, and we also have, as part of life cycle, is we have unplanned audit, and actually have consultancy comes in and tests our system.
Hello, everyone. I would like to ask you regarding the topic of integration and interfacing. So we have, the most common is the BPSES interfacing with the SIS, but also we have interfaced motor controllers with the SIS systems, typically hardwired for the motor trips during the sequence. Have you explored the possibility of utilizing Ethernet-based safety-certified communication protocols now that more and more motor control vendors are putting intelligent motors out there that are also SIL-certified and could potentially reduce the hard wires, the interposing relays that you have between the SAS and the MCCs?
We're starting to see more implementation of the smart motor circuits, but most of that interface is for the normal, what we would consider regulatory control of those motors, our shutdowns, if those motors are used in protective functions, they are still done independently through hardwired. Now, that's not to say down the road we wouldn't consider something that is a SIL certified protocol, ensuring that that information is also manageable into our safety logic solver. But we're not there yet. We're still using the standard approach. And we also have different detailed design on motor circuit designs depending on whether a motor is classified as SIL 1, SIL 2, SIL 3. And obviously the SIL 3 design is a little more complex, a little more fault tolerance built in, and in all those cases it's still done independent shutdown.
So I think conceptually there's nothing wrong with that. It does bring a couple vulnerabilities with it. So certainly there's safety rated Ethernet. There's a cybersecurity risk, especially as you start making an I/O network that's much more interconnected and it's going to have more access. Then there's also, and I don't know the specific of the motor controllers you're talking about. There's a lot of SIL-rated motor controllers, but sometimes that's for safe talk off only, which might be a discrete input. So often they can bypass a lot of the code in the motor controller because it's not in the safety critical path for a safe torque off command, which might be a discrete input. So that what you said absolutely could be achieved, and that would be really then understanding the system, because sometimes what we find is people say, well, I bought this SIL-rated XYZ, and then I connected it, and they say, oh, can you come in and say we did it right? And we go, okay, yeah, but I actually had a customer who said, the brochure said SIL 2 on the front, they bought it, they put it in, it's like, well, that's not a SIL-rated device. Well, no, the brochure said SIL 2. So you got to really understand that system and how well it's, what's the safety critical path. And then I think the cyber is the issue with broadening field networks with high capability. Hardwired doesn't concern me as much because you got to get in there and somehow pretend you're a transmitter. So you got to get in the plant, you got to connect to it. Wireless heart for remote, okay, now you've got something out there looking for a heart signal, and so those are considerations that we would bring up.
I think from a viewpoint, if the technology is there and it met all the requirement, I don't see any problem for us to implement where it is right. One of our struggle is does it meet the purpose? What's wrong with the system now, the way we do it now? Because we always struggle is, again, OC, right? We have region in the world that say, don't change anything because I cannot train our people fast enough to move on to other stuff. So specifically, like we try to change one time our design for motor interface. The pushback, no, keep it hardwired because our people train on that. And sure enough, when we do a value case for the benefit that we're getting for changing, it addresses some of the current problem, but it's not really not big enough case to make the change.
All right, so I have kind of another question, and kind of maybe it's the first question that...
You're using up your credits, Louis.
The first question that Mark asked in his title, right? So from what I'm listening to the panel discussion, I mean, my interpretation of the answers is it really doesn't matter because at the end of the day, it goes back to the principle, let's say the first principles of functional safety and security lifecycle management, right? And the proper application of the standards in the design, validation, verification, etc. Now, the question behind that, so if number one, did I get it right? I understand that that's what you're trying to say. And number two, is the industry at the level that those first principles of functional safety and security lifecycle management understood well enough so we can have secure and safe implementations regardless of the technology that is applied?
Well, I think we're good. But obviously, as technology changes, and you've even heard some of the higher level panel discussions talk about the people aspects. Years ago when I started my career, when I had a question, the typical response was, well, if so-and-so doesn't know, just ask one of the graybeards. Well, now I am a graybeard. And a lot of the graybeards are going to be retiring in the next 5 to 10 years. So there's an importance around not so much the what, but the why, and making sure that the why information that gets disseminated down into, if you will, the new guard, the new workers coming in. And as long as we still have our governing bodies of the standards and international standards as it applies to cybersecurity, as it applies to process safety, and we continue as operating companies to stay engaged in those standards and make sure that those standards are evolving to stay abreast of the technological advances, then I think we're going to be okay. We still have to keep the information in mind regarding, the safety life cycle, the cyber life cycle, risk-based approach, and ensuring that things are done in an appropriate fashion, even as technology changes, even as more and more devices are getting connected. We still have to make sure that we have that focus on, safety life cycle and cyber life cycle management and a risk-based approach.
I agree completely. The only thing I'd like to add, if I could, is as the new technologies come, and the rate of change of technology is high, okay? As new technologies come, you have to think about the failure mechanisms that can bring to the table that weren't there before, okay? And so that can be true in application A and not necessarily true in application B. So getting involved with suppliers, getting involved with standards, understanding the new technology and what that brings to the table as a pluses and a minuses in terms of those failure mechanisms, and bring that up, to your process safety guy, to your LOPAs, understanding that, and then again, trust the process, work through the system in terms of the SIL verification, the testing that's required, and of course the cyber side.
I think those are both two good points, and specifically, the retraining and continued training. A golf instructor said, golf swings are perishable skills. Mine's more perishable than others, but if you're not doing it, it's going to go away. So that training and continually training the organization of even what the basics are, that has to always go on, and there's a lot of new technology that gets into products that brings vulnerabilities, small geometry silicon, which background radiation can change the bits. So, hey, you can design safety systems using it. You have to do things a certain way, and it'll mitigate it or correct for it, but if you don't, it won't. And I think we're going to see more of a push. Or one place we can look is we can look at the safety standards in other industries like automotive, and they're driving more rigorous analysis for dependent failure analysis on hardware, software, silicon. They're trying to put everything into one chip. They're doing control, and it's safety critical, and that's the way cars are going to be. So we can kind of look outside and then see what's going to come into our industry in 5 or 10 years, so we can get some heads up. But we can get there, but the world is changing so fast that we're going to have to, keep working hard like we are.
From our point of view is, especially technology change at a fast pace. We don't actively go out there and say what can we implement or not. What we have a tendency to do is really look at what issue we have, what kind of focus we have, and what technology can help us address those things. So give you an example. Right now, one of our focus is process safety management or safety life cycle. One of our biggest issues is documentation. So documentation all the way from design and the management life cycle. So now we're looking at any tool out there or technology, and we even partner with our common supplier and say, our challenges is, as you go through design, I'll give you some example, specific case. You do your cause and effect, and you do your programming and all these. It changed hand, and how do we document that, and can we make it more transparent or integrated, right? So we work with our system supplier. We look at different technology that help us have one system that do them all. So we built that in. And that addressed both of our documentation, but also of our aging workforce, right, and skill set. And then now we embark into, okay, do we have a tool that help us keep the documentation, a system for managing the life cycle of it? So we tend to look for really what's our focus, what's really one of our biggest issue, and we'll try go out and look at where technology can help us there. So I'll turn that around, right? So I would, as I guess in the industry, the supplier is really talk to the end user and understand what their need is.
Okay, and with that, I think we're out of time. So please thank my panel.